All right, Mr. G Math coming at you live Friday morning. Lesson 444. We're going to put all the good stuff we did in Unit 4 here. We're going to put it together, be able to sketch, be able to graph relative max, relative min, points of inflection, intercepts, domain. Like we're going to put all of this together, okay? So, in this unit, they call it a recipe, whatever. They're just saying, like, here's a list of things that we need to be able to do when we see a function, okay? So can you actually understand and give the domain of the function? We're going to practice that. What's the key thing for the domain, right, is the x. Is there anything that x can't be? That's what we're looking for. Reduce means, is it in lowest form? Can you factor it and reduce it down? Yay. 3, vertical asymptotes and holes. If something divides out, it creates a hole. If something stays in the denominator, it creates a vertical asymptote. X and Y intercepts. The X-intercept is the 0 of the top. So if you take the top part of the fraction equal to 0 and solve it, those are the X-intercepts. The Y-intercept, wherever there's an X, you plug in 0 and then solve it. We'll go through it when we see a problem. Find the end behavior. So the power terms, right, give us the end behavior. And if it's a rational function, we look at the power term over the power term, right, to see what way the ends are going. Check for symmetry, optional, which usually means, like, don't do it. But 7, right, whenever you do, like, an application, it says optional. Don't you just, like, pretend like you don't read it, right? You just you go down to the next one. Optional means I don't have to think about it. 7, but we might talk about it. Find increasing and decreasing intervals. That has to do with what? The first derivative, and it's the first derivative test, and relative extrema, which means relative max or min, also from the first derivative. And then what our last lesson was on, Carmen was zoning out on me. Did you hear that on the video? She was like daydreaming or being mad about somebody. I won't say that on the video, but you're mad. So last one is concavity. And is there points of inflection where the concavity changes, right? And then we put it all together on a graph. So, do you see the big picture of the lesson? Breathe. We're just going to go one step at a time. So, look at number 1. Be happy. The function's given. What else is given? The first derivative's given. What else is given? Second derivative, okay? So, the act of having to find the first and second derivative are already done for you. Yay. What's the domain? Which one would I look at? The function. We're not going to call it the original. It's not like Kentucky Fried Chicken. So it's the function, the first derivative, and the second derivative, right? We can name them, okay? So to find the domain, which one do I look at? The function. And if it's rational, which it is, you look at the denominator. Is there anything that you plug in for x that would make the denominator 0? And the answer is no. So it's all real numbers. Now, why is the answer no? X squared plus 1, a negative number, 0, or a positive number, none of that would produce an answer that's 0. Correct? You could also take the denominator, x squared plus 1, make it equal to 0, and try to solve it. But you'd find that the answers are imaginary. There's no real answer that would solve that equation. Say yes. Yes. VA. Vertical asymptotes. Look at the denominator. Why is there no vertical asymptotes? There's nothing that makes it undefined, right? Why are there no holes? There's nothing that makes it undefined, right? The denominator, right? Holes in vertical asymptotes. If there's a value for x that makes the bottom, right, 0, undefined, yeah, but there's nothing. It's all good. All numbers you put in for x give you an answer. That means this function is continuous. Got that? Now, it may not be differentiable everywhere, because those are two different things, but it's continuous. All right, what is the x-intercept? Where do I look? Which equation? The function and the numerator. If you take the numerator equal to 0 and solve it, the answer would be obviously 0. Correct? Here, I'll even on the side. 2x cubed equal to 0. If you went 0 divided by 2, 0. The cube root of 0, 0. Or just use your brain, right? What number do you plug in that would make it 0? 0. Beautiful. Now I'm going to say something else. You got this. Do you think that's an odd or even x-intercept? What do I even mean by that? Odd or even means look at the exponent. It's an odd or even exponent. And what does that tell me? That means that 0 is it going to cross or touch? An odd exponent means it's going to cross, I know, 1,000 years ago. And an even exponent means it would just touch. So if that said 2x squared, then we would know at that x-intercept it would touch and not cross over. Okay. The y-intercept. Wherever there's an x, you plug in 0. Do it mentally. And I'm going to tell you that if the x-intercept is 0, the y-intercept has to be 0. They go together. But when you plug in 0 for x, guess what 2 times 0 cubed is? And then 0 divided by anything is 0. EB means end behavior. What do you think the end behavior? The right end and the left end. What does that come from? The power terms. What's the power term on top? I'm going to do that on the side. What's the power term on the bottom? So when I reduce it down, what does it reduce down to? 2x. 2x is a slanted line that goes up to the and down to the. Did it. So you can say the right end up, just for fun, and the left end down. We won't even write it as a limit in infinity and so on. Just very casual right now. Symmetry, it says optional, right? Let's go down. Relative max. We're going to look off the graph and go back and see if we see it rather than from the equation. Relative max. Which do I look at? The function, the first derivative, or the second derivative? Good. So when I look at the first derivative, if you made the numerator equal to 0, the first factor wouldn't give you an answer, right? If you take x squared plus 3 equal to 0, it's going to be imaginary. But if you take 2x squared equal to 0, again, the answer is going to be what number? 0. So when I do a first derivative number line, can I do it right above here? The only critical number is 0. Why? Because there's nothing that makes it undefined, correct, in the bottom? Or am I lying? Nope, I'm not lying. X squared plus 1, if you plug in a negative number, 0, or a positive number, that will never be undefined. So the only number is 0. Oh, you know what else up here? What else did I see? No. First, it's only 0. I'm right. When you plug in a number like 1 million, the answer is going to be positive or negative. Good. When you plug in a number like negative 1 million, is the answer positive or negative? Good, because of the even exponents, right, that you see? Now, what does that tell you about 0? It is not a relative max or a relative min, right? So what relative max or mins do we have? And the answer is none. We don't have any. That means there's not a curving point, right, in terms of a high or low point. PI, which I hate, point of inflection, what would I do? Look over here. So if I look at negative 4x, right, I'm going to do that here on the side. Negative 4x equal to 0, what does x equal? 0. Notice this one's different. X squared subtract 3 is different than x squared plus 3. If I go x squared subtract 3, if I solve this, add 3 to the other side and take the square root, I know it's irrational, but it's still real. So notice how I took each factor. What did I do to each factor? Make it equal to 0, and I solved it. So what did I find? I found the critical numbers. There's nothing that makes the bottom 0. So there's nothing that makes it undefined. So how many critical numbers do I have? And you have to get over the fact that it's irrational. So 0, positive root 3, and negative root 3. This is a second derivative number line. What am I testing for? Concavity, right? So let's look between 0 and root 3. Between root 3 and so on. If I plug in 1 million into this top one, will the answer be positive or negative? Positive, negative, positive. The whole thing will end up being negative. You have to quickly, who cares about the exact number, but is it positive or negative? If I plug in a number between 0 and root 3, like positive 1, if I plug in positive 1 on top, that's a negative times a negative, which is positive, divided by a positive, which is positive. I'm seeing where it smiles, and I'm seeing where it frowns. Between 0 and 1, negative 1. Plug negative 1 in, and it's negative. Plug negative 1 in, and it's positive. So a negative and a positive make it negative. Divided by a positive is negative. Put in negative 1 billion. A negative times a negative make it positive, positive over positive. All of it is positive. And what I just found here was smile, frown, smile, frown. Where are the point of inflections? Where does it change from this to that? 0 and at root 3. So let's plug in some numbers now. So at 0, if I plug it into the function, plug 0 in for x, what's the answer? What's the y coordinate? So can you put that point right there? At positive root 3, let's use your calculator. I don't want you to get a headache. If I put in positive root 3, let's see what we got. So, do you know that right now we don't have our graphing calculator, so I'm just going to type this in to Desmos. So, I'm going to type in 2, and it's root 3. And it's 2x cubed, correct? And then I'm going to divide. And then the bottom is 2 squared plus 1. But what number? Oh, I'm not putting in 2, right? What number am I putting in? Root 3. So let's put in root 3. Plus 1. All right. Did I type that in right? So wherever there's an x, I put in root 3. And Desmos is beautiful for me. I'm going to round it to 2.6. Is that okay? So when I put in positive root 3, what's the answer about? 2.6. When I put in negative root 3, I'm not going to get a headache. Guess what I'm going to just do? Put in negative. And if you put in a... Why are you doing that to me? Oh. There it is. So if I put in a negative, it's negative 2.6, which actually gives me a clue of symmetry. You could have guessed that? I agree. That means, you know what type of function is this symmetry-wise? It's an odd function. Because it's going to look like quadrant 1 and quadrant 3. But let's put it together now. So, can you find where root 3 is not quite 2? Right? Root 4 is 2. So, right before 2, and you're going to go up to 2.6. So, like, just approximate where that is. And at negative, root 3 is not quite negative 2. Down here. Beautiful. We're just approximating. Now, what's some things I care about? So, I care that it smiles or frowns, and I care, is it increasing or decreasing? What do we know about increasing and decreasing? It's positive, positive. What does that mean? It increases everywhere. So from left to right, what direction is it going? Up. It never changes direction that way, right? So when I'm going up, is it smile or frown? So let's just start with easy. Like between 0 and root 3, smile or frown? So can you do a smile? Thank you. What happens after root 3? From root 3 and on, what does it do? Okay? What happens between negative root 3 and 0? What does it do? And then what happens from negative root 3 and to the left? It doesn't frown, it smiles. if I did this in Desmos, if you actually just saw what the function looks like, it would be y equals 2x cubed. And then in the denominator was x squared plus 1. Oh, is that all squared? No, just that. Now, if I look at it this way, let me get in here, that if you don't zoom in, you won't see the concavity change. So do you see the smile on the right? Does the smile should change when? And it's really subtle, right? It smiles. It looks like a straight line here, but it's not. That you can see the frown and the smile. It's difficult to see the end behavior. Maybe if I zoom out, you can see a curve. Now it's going to look like a straight line. But if we can zoom in enough, there is a concavity change at root 3. Should I put a point? At where? How do I even do that? I don't know.
On the next box. You put X on.
And so when x equals root 3,
you put in the original one, you put in the function f of x.
oh,
And then on the next one you put f.
f at root 3. Is that right?
Yes.
I like how you guys think.
Thanks.
And will it show up here?
Yeah, it usually does.
But we know the point. Why don't you just put the point in?
I know. I don't have, like here it's
No,
like
on the.
so somewhere here it's 2.598. Somewhere here the concavity
Go back
changes.
to the number 2 box.
All right, I don't care.
Mine
All right, we just went down a rabbit hole. We're going to come out right now. 2. All right, let's do this. Domain, look at the denominator. If you look at the denominator, I want you to notice it is factorable. Do you see that? So I'm going to write it here on the right. I'm going to write it factorable. So the numerator is 3x minus 2, but the denominator can be written as x minus 1 squared. Two numbers that multiply to positive 1 and add to negative 2. So it's x subtract 1 squared. So what's the domain? What value can x not be? Good. Write that down. Is there a vertical asymptote? Yep. Is there anything that simplifies here then? So at x equals 1 is what? At x equals 1 is a vertical asymptote. Is there any holes here? No. When would there be a hole? If something simplified. X-intercept. Look on top. If you take the top equal to 0, you add 2 and divide by 3, the x-intercept's at 2/3. If I plug in 0 for x and solve it, negative 2 over positive 1.
Wait,
Mm-hmm.
you're using the first one, right?
Yeah, just use the function. Top of the fraction equal to 0. All of this is just the function, not any derivatives yet. Y-intercept, where there's an x, plug in 0. So that's negative 2 over positive 1. That's negative 2. What's the end behavior? What's the power term on top? No. 3x, the power term on the bottom. X squared. What you should notice about this is that the power term, the degree on top is smaller. Whenever the degree on top is smaller, yeah. So the end behavior is the same as the horizontal asymptote. In this case, the right and left end is going to get closer and closer to 0. Symmetry, where it's optional. Relative max and relative min. That requires what? That requires a first derivative line, right? So when I look at the derivative, right, only the top right now, if you solve for x, what answer would you get? Subtract 1 and divide by negative 3. and negative divided by negative is positive a third, why will I not put down what makes it undefined? Like positive 1 makes it undefined, but I'm not putting that on my number line. Do you know why? Because it's a vertical asymptote. It can't be a point, right? It's not a relative max or min. It's a vertical asymptote, right?
But don't we usually?
So we can still put it on there, but we're not going to get confused, right? At positive 1 is what? So can it be a relative max or min there? No. So when I plug in, we can still see where it's increasing and decreasing, but it's not a relative max or min. So if I plug in a number like 1 billion to the top, will the answer be positive or negative? Plug in a number bigger than 1, will the answer be positive or negative? So the top, if you plug in 1 billion, will be negative, and the bottom will be positive. So a negative divided by a positive would be negative. Between 1/3 and 1 is like 2/3. If I plug in 2/3, the bottom is negative, and the top is negative. So a negative divided by negative is positive. If I plug in 0, we would get a positive over a negative. So this, what did I just find? Where it's increasing and decreasing. What would a second, so what does 1/3 give me? Which one? Which one? 1/3 gives me the minimum, right? Negative to positive. And I won't make you do it. That y coordinate is negative 9 over 4. So you know where the point is, where there's a minimum. Point of inflection, which derivative do I look at? So again, it can't be a point where it's an asymptote, right? So where am I looking for in terms of that? Is that what an answer? Take the top equal to 0. What's the answer for x? So I'm going to test 0. I can also test positive 1, but that's only for concavity, right? Not for a point. Because at 1 it's undefined. When you plug in a number like 1 billion, the answer is positive. When you plug in 1/2, this even exponent makes it positive over positive, which is positive. Remember, this is an asymptote. Plug in a number that's negative. Any negative number, a negative divided by a positive is negative. So where is there a point of inflection? When x equals 0, when you plug in 0 here, all is negative 2. You can do it here too. 0, it's negative 2 over positive 1. So it's 0 and negative 2. By the way, that's the y-intercept. All right, let's put the points on the graph. So 0 and negative 2. Where's the x-intercept? Is at 2/3. We're going to approximate where that is. At 1, there's a vertical asymptote. And now we're going to worry about where it smiles or frowns. Oh, we also have a horizontal asymptote. Where's the horizontal asymptote? At 0. It's okay if it crosses the horizontal. The horizontal tells me the end behavior, not the middle part. So, yeah. What did we do with the second derivative? To see if it smiles or frowns. So, when it's greater than 1, what is the shape going to look like? It smiles, correct? So it smiles, but the right end behavior goes to 0, and know that it's going to go to positive infinity on the right side. On the left side, what happens between 0 and 1? It also does what? Smiles. This point down here is also a relative. Where's the relative minimum? At 1/3 and negative 9 over 4. So there's a point that's a little lower than the y-intercept. And that's going to be relative min. So where does it smile? It smiles all the way to the y-intercept. Can you do that? Can you smile there? Even if it's a hard lesson right now? Smile. And then after it smiles, what does it do? it frowns all the way to the end behavior. So the frown, the smile, and the smile. And you put it all together. We're not going to go on Desmos. You can do that on your own and see what the graph looks like that we did. We have one more and then we're done. Okay? All right, here we go. We're going to have it on video so that you can watch this a second time, right? To get this. Let's say that this is a challenging lesson, right? Does that mean you tune out, frustrated, I'm not listening to you? Or does that mean you're trying to work harder, right, to get this? The domain, look at the denominator. Is there anything that makes the domain 0? Good. Can you see a negative number, 0, and a positive number? There's nothing that would make that 0. So what's the domain? All real numbers. Vertical asymptote. What would I do to find the vertical asymptote? Or the holes. And why is it none for both? Because the domain is all real numbers. That means this function is continuous. Right? If there's a hole or a vertical asymptote, it wouldn't be continuous. Easy. X-Intercept. Look on top. What makes the top 0? That would be 0. Is it odd or even? Why? Because the exponent is odd. That tells me what happens. It crosses at 0. The y-intercept. What number do I put in for x? 0. What did I tell you 2 seconds ago? That if x-intercept is 0, then the y-intercept must be 0. What's the end behavior? What do I look at? We're going to be really careful here. So, can you see the power terms here? So, on top, the power term is x, but on the bottom, it's a quadratic. You know when you solve a quadratic, the square root of x squared? The answer could be positive or negative. So one end behavior is positive 1, and the other end behavior is negative 1. So we have positive 1, and we have negative 1. Just put them here. No one's absent. I'll hand it to them. Thanks, Daniel. Symmetry is optional. Relative maximum. What do I do for that? What do I look at? Is there anything that makes the top 0? Is there anything that makes the bottom 0? So is there any relative max or min here? None. How would I find the point of inflection? What would I look at? Look at the top. Is there anything that makes that top 0? Yes. What? 0. And so I'm going to do a second derivative number line. I'm also going to do a first derivative number line, but you're going to see that in a second. It's really quick. 0. If I plug in 1 billion, the answer is going to be a negative over a positive makes it negative. If I plug in negative 1 billion, it's positive over positive, which is positive. The left side smiles and the right side frowns. If I look at the first derivative only, no matter what number I plug in for x, the answer is always positive. What does that mean? It's increasing left to right everywhere. So from left to right, it's going up. Low to high, left to right, all the way. No matter what number I plug in for x, the answer is always positive. So that function is forever increasing. Okay, when I plug in 0 into the function, the answer is 0. So I want to put 0, 0 here. We have 2 horizontal asymptotes at y equals 1 and at y equals negative 1. So at positive 1 and at negative 1. So what happens from 0 to the right? It increases, which means it goes up, right? Does it frown or does it smile? Frown. So can you draw it so it frowns? So it curves like a frown. Like if I did the full frown, can you see that the face is going down if I did the full one? But the right end behavior is going to what value here? To 1. What happens from right to left? Is it smiling or frowning? So it's smiling. And again, if I connected this as a smile, you could see that, right? But it's not the full smile. And the left end behavior is going to what number? -1. It's putting the pieces together, right? That's good work for this weekend, right? To practice, don't give up, believe. And there's going to be a quiz on this on Tuesday.